Hey guys, Avi here, and welcome back to TheCodex. In this video, we're continuing our project, Handwritten Digit Recognition with Python, and in this video, we're going to go ahead and actually visualize the data that was given to us in the MNIST format, and then finally, create our train and test datasets with the train test split function. So, first thing first, let's visualize the actual array of data that was given to us. We saw in the last video that if we print out mnist.data.shape, let's say the first one, mnist.data 0, this gives us an array of all these different digits that correspond to an RGB value from 0 to 255. And that again corresponds to kind of a pixelated value of between black and white that we want to display. And so what we're going to go ahead and do here is we're going to create a figure and plot the first 5 numbers of our array. So here, go ahead and type plt.figure. And we're going to create kind of 5 different charts, each one being, let's say, a 4x4. So we're going to say here fig size is going to be equal to 20, 4. And so we'll be able to fit 5 charts in a nice row. And then we're going to say kind of here for index, and we want to access both the array and the label of this data. So we're going to say image, label in, and then we can enumerate over kind of both of these things by using the zip function in Python. And we're zipping together our fetch OpenML dataset, so MNIST, and here we're fetching the MNIST first 5 values. So we're saying dot data, here the first 5, so up to 5. And then after that, we're going to zip together MNIST labels, so dot target, and then get the first 5. And so once we've done that, we're iterating and getting the image, label, and index. We're going to go ahead and create a subplot. And if you remember the subplot command from a previous project, what it does is it takes in which chart is this, how many kind of like, it's a 1x5 chart, and then which position in this chart is going to be index plus 1. So index here goes from 0 up to 4, and we're going to go ahead and add 1 to that to get 1 to 5. So we're getting our subplot, and inside of this subplot, we're going to run the command plt.imshow. And imshow or imshow takes in an array and plots those arrays as an RGB value. And so here we're going to take our kind of one-dimensional array of 784 digits that you see right over here and convert this into a two-dimensional array that's of size 28 by 28. And that's going to look something like this. So we're going to say plt.imshow np.reshape, and we're going to pass in 28, 28. But before we do that, we want to go ahead and specify what are we reshaping. So let me go ahead and make a small modification here. We're specifying the image, which is going to be our array, and we're reshaping it to be a size of 28 by 28. And once you do that, you can also specify what the color map should be. And so the color map here, should be, let's go ahead and make it black and white. So gray in quotation marks should do it. So what we've done is 2 things. We have iterated over a combination of the array data as well as the label data. And for each array and label that we get, we're creating a subplot inside of our figure, and we're showing or plotting that kind of 28 by 28 array as a pixelated version of itself. And then let's go ahead and for now, just give it a title, plt.title, and I'm going to specify here the number should be %s, and we're going to pass in the label, which is specified in the enumerate function over here. And so we're going to specify that this is what the number should be. And now if we run this, we see 50419 and the numbers on top. So this again is the raw data that we're getting from MNIST. It originally was a 784 long array, 1x784 long array of RGB values. And we're converting that into a 28 by 28 two-dimensional array and plotting that with imshow. So now that we have this image and we're plotting these images, we can see exactly what our data looks like. And we're going to take this data and apply logistic regression on it to essentially predict if I'm given a new number that looks something like this with some RGB values in a 784 long array, what number is it going to be? And so that is the beauty of logistic regression, where it'll classify the number we provide as one of the 10 digits that are possible. So here we can end this video by specifying our train test for both the X and Y of our data set. So here, I'm going to go ahead and create X train, X test, Y train, and Y test. So X underscore train, X underscore test, y underscore train and y underscore test. And again, if you remember, using the very simple function from above, train test split, we can go ahead and just copy that down over here and pass in our mnist.data. So again, we're training on our x. What are our x values here? The features that we're passing in is going to be this set 1 by 784 array. And we're going to go ahead and specify here that the labels will just be mnist.target. And the target here is going to be the labels 50419 that you saw above for the matplotlib titles. Now that we have that, let's go ahead and also specify the test size. So the test size here, in general, a good notion principle is the 80-20 split. So we're going to specify here test underscore size to be equal to 0.2. So we have x train, x test, y train, and y test. And now if we go ahead and run this, we should now get our data correctly split into a 4-to-1 kind of ratio of train data and test data. Now that we have this, in the next video, we'll go ahead and learn about logistic regression and apply that on these numbers. Thanks so much for listening, and I will see you in the next video.